operators, which are symbols used along data types. So first, the simplest one is the equal sign, which is called the assignment. So the equal sign is used to assign the value of the variable on the right to the variable that's on the left side. Okay, so here in this example, let number a is equal to 12. So we have a number a that stores the value 12. Now we have var number b that is equal to number a. So the value on the right, which is number a, gets assigned to number b, which is on the left. So number b is now equal to 12 as well. Okay? Alright, so I repeat again. The value or the variable that's on the left receives the value that's on the right of this equal sign. Okay? So they both now are equal to 12. Alright, next ones are the basic arithmetic operations. You're already familiar with them. This is just basic math: plus, minus, multiplication, and division. Okay, so here we have two numbers, an even number that's equal to 6, and the odd number that's equal to 3. So what do we do here? For the addition, we do the addition is equal to the even number plus the odd number. So obviously, the addition stores the value of 6 plus 3, which is 9. Then subtract is now equal to the even number minus the odd number. So the minus sign, 6 minus 3, gives a value of 3. So subtract, receive the value 3. Then var multiplication is equal to the even number times the odd number. So it's 6 times 3, 18. Multiplication stores the value 18. Now var division is equal to the even number divided by the odd number. So as you can see, 6 divided by 3, the value is 2. So division receives the value 2. Alright, basic arithmetic operator. Now the modulus sign, that's like a person sign. Okay, we call that modulus. This is the remaining value of a division. For those of you who don't really know, it's not very used that often, but it's pretty handy when it comes to programming. So here in this example, we have two numbers. Number a, that stores the value of 11, and number b, that stores the value of 4. So what we do is that we let the number c equal to the number a percent number b, which is also read number a modulus number b. So if you think about it, number a is 11 and number b is 4. So it's the way it works is that the value stored in number c will be 3. How? Because it's number a divided by number b. So what's number a divided by number b? It's 11 divided by 4. And 4 goes only 2 times, right? In 11. So you do 4 times 2, which is 8. And from 8 to 11, you need to add 3. 8 plus 3 is 11. So this number 3 is the remainder, okay? 11 minus 8 is equal to 3. That's how you get the remainder. Now the equality check, that's when you compare if two values are equal or not. And the result is always of bool type or boolean, which is true or false. It cannot be anything else. So in this example, we have three numbers. Number a, that's 11, b, that's 4, and number c, that's 4 as well. So, and we do result 1. So let result 1 equal to number a is equal to number b. So we pretty much are asking a question here. Is number a equal to number b? So result 1 would be false because number a is 11 and number b is 4, right? So 11 is not equal to 4, so it's false, okay? Then we have result 2, which is let result 2 equal to number b equal number c. So we're asking ourselves, is number b equal to number c? And result 2 is going to be yes or true. Why? Because we know that b is 4 and c is 4. So 4 is indeed equal to 4 itself. So the result is true. Now, greater or less than equal. So here we're comparing if a value is greater or equal than another value. So the value on the left to the sign that's to the value on the right of it. So the value is always a boolean, true or false. That's the result here. So again, number a is 11, b and c are 4. So result 1 is number a greater or equal to number b? So we basically in result 1 we're asking, is 11 greater or equal than 4? Yes, obviously, because 11 is greater than 4, right? So the result is true. Okay, result 1 equals true. Now, result 2. Let result 2 equal to, we say here, is number B less than number C? And obviously, we have B that's the same as C, so B is not less than C. B is equal to C. So if it's not less than C, then it's false, right? Because 4 is not less than 4. Now, result 3, is number A less or equal than number B? Now, number A is 11, and we're asking, is 11 less or equal than 4? Obviously, it's not. So result 3 will be false, okay? 11 is not less or equal to 4. Now, logical operator OR. That's two pipes. It reads OR, or two adjacent pipe characters, okay? We use that to chain operations in just one command, okay? So here, as you can see, you have, in the first example, 4 is greater or equal than 5, or 3 is greater or equal than 5. Now, obviously, the first operation, 4 is greater or equal than 5, is false, right? It's obvious that 4 is less than 5. It's not greater or equal. And the second operation, 3 is greater or equal than 5, is obviously false as well, which means false or false. And the answer is only false, because that's all you have. Then you have, in the second example, 4 is greater or equal than 5, or 3 is greater or equal than 1. Now, 4 is not greater or equal than 5, but 3 is greater or equal than 1. Yes, 3 is obviously greater than 1. So the last one is true. So we say false or true. And when you have one true, then the final result is true. Okay? Now, a note, when you use the OR operator, if one of the operation is true, then the final result is true all the time. Okay? So you only need to have one operation that's true, and the final result is always true. Now, the next logical operator is the AND sign, okay, which is two adjacent ampersand characters. So it's used to chain operation also in one command. 4 is greater or equal than 5, and 3 is greater or equal than 5. So it's false and false. The final result is false. Now, the next operation is 4 is greater or equal than 5, and 3 is greater or equal than 1. We have false and true, because 3 is greater than 1. But the final answer is false here. It's different than OR in the sense that with the AND operation, you need to have all operations to be true to have the result true. If not all the operations are true, so it means that if only one of the operations is false, then the result is right away false. Okay? So I repeat, all of them need to be true for the result to be true. Otherwise, it's false. Okay, and so look in the final answer, the final line, 1 is equal to 1, and 2 is equal to 2, and 3 is equal to 3, and 10 is equal to 10. Here, there's 4 operations that are all chained with the ampersands, and yes, every one of them are true, so the final result is true. Alright, and that's all you need to know for the basic operators. See you guys in the next lecture.